Welcome to Shanti-Peace for Mathematics. In this video, we'll talking some standard type of first order partial differential equation which can be solved using Charpit's method. So in that, a type 1 is the equation contains only variables p and q, where we know that the p is del z by del x and q is del z by del y. That means the given partial differential equation does not involve the variables x, y and z explicitly. The given partial differential equation does not involve x, y and z explicitly. If you use the Charpit's method, then the auxiliary equations are dx upon fp, dy upon fq, dz upon pft plus qfq plus equal to minus dp upon fx plus pfz is equal to minus dq upon fy plus q fz. Now here this function is only a function of p and q. It is independent of x, y and z. So this Charpit's auxiliary equation will convert into form of dx upon fp is equal to dy upon fq is equal to dz upon pfp plus qfq is equal to minus dp upon 0 and minus dq upon 0. Because fx is 0, it is independent of x, and fz is also 0, it is independent of z. So that's why here you will have a 0, here is also 0. So if we solve this last two equation, then we get, if I use the last equation, then dp is equal to 0, and that will give me a p is some constant where a is constant, and we have the equation f of p dq equal to 0. So using this equation, we can able to find out what will be the value of q in terms of a. So that will give me, let's say, for if you solve this one, that means f of aq, if I substitute the value of p here, equal to 0, for q equal to q of a, then the Pfaffian equation dz is equal to phi xyz dx plus xi xyz dy will be converted to dz equal to p dx plus xi, that is q of a dy. And if you integrate both sides, the answer or the final complete integral, the value of p we have, it is a. So it is, instead of p we have here a, it is ax plus q into ay plus some another constant b. So that is the complete integral if your differential equation is of the form f of pq equal to 0, it's given. Let's solve some examples based on this. So question, find the complete integral of f of pq is equal to p plus q minus pq equal to 0. So as per the previous situation, this is a function of only p and q. So we'll directly, to solve this one, we'll just directly put q equal to a. Then we'll have a plus q minus aq equal to 0. Because as you see that we have got the p equal to 0 using this Charpit's method. So we'll directly put p equal to constant, and we have obtained the value of q in terms of a. So that we are trying to get here. So that will give me q into 1 minus a is equal to minus a. So q will be a upon a minus 1. And if I have now the equation, that is a Pfaffian equation dz phi xyz dx plus xi xyz dy, this equation will change to a dx plus xi is a upon a minus 1 dy. So hence the complete integral by taking integration both sides will have z is equal to ax plus a by a minus 1 y plus some constant b. So which is the required complete integral we can got from this. So this is the first type. Now the type 2 is it will have a function of z, p and q equal to 0. That means the given P.D.E does not involve x and y explicitly. So it is only a function of z, p and q. Then we know that the auxiliary equations are dx upon fp, dy upon fq, dz upon p fp plus q fq. This is the Charpit's equation where we have dz upon fx. As you see that the equations are fx plus p fz, but here it is independent of z, x and y is there, so fx is 0. So you will have only dp upon minus p fz and is equal to dq upon minus p fz, sorry q fz, dq upon minus q fz. So if I can solve this now, fz will get cancelled out the last two equations, then the equation will change to dp upon minus p is equal to dq upon minus q. So that will be written as dp upon p is equal to dq upon q. So if I take the log both sides, then it will gives me ln of p is equal to ln of q plus ln of a, where a is a constant. So the value of p we have a into q, and therefore we need to now solve the equation f, and this is the equation g, and obtain the value of p in terms of x, y, z. So therefore that f of z and the value of p is this, is a q and q equal to 0, or you can just write down this is in terms of q of az, and then the value of p will be a into q of az, and then we need to solve this dz is equal to phi. The value of phi is this, a into q of az dx plus q of az dy. So that can be integrable. So the finally what is the things we got, it is integration dz by q of az is equal to ax plus y plus some constant b is the complete integral we get. So let us solve one examples based on this. Find the complete integral of the equation z pq minus p minus q equal to 0. So first of all you should note that this equation it is only in terms of p, q and z. There is no involved about x and y. So as per this previous discussion we have to substitute p equal to aq in this equation. So putting p equal to aq in above equation, we get z a q minus a minus 1 equal to 0. So that will implies the value of q we can get, that is z a q equal to a plus 1. So that will be q equal to a plus 1 upon z into a. And once we have the value of q, that will also gives me the value of p in terms of z, that will be a into a plus 1 upon za. This a is get cancelled out, so the finally you will have a plus 1 upon z. So now the Pfaffian equation dz is equal to phi of xyz. The phi of xyz is exactly the value of p, which we have a plus 1 by z dx plus the value of q, that is a plus 1 by a into z dy. So if I multiply both sides by z, then it will be z dz is equal to a plus 1 dz plus a plus 1 by a dy. And if I take the integration both the sides, then this will give me z square by 2. I take that 2 on the other side, that is 2 into a plus 1 x plus a plus 1 by a into 2 y plus some another constant b will be there. So this is the required complete integral which we get. Now let us discuss the type 3. So the type 3 differential equation is of the form is a separate type, that is xp here, and on the other side it is the function of y cube. So it is a separable type differential equation is given. Then in that case the auxiliary equation are, that is dx upon fp. Fp, that means, so actually the function of f of xyz, it is xyz pq is equal to 0, it will be this equation, that is g of xp minus h of yq equal to 0. But if I take the differentiation of the f function with respect to p, that is exactly the differentiation of this function with respect to p, because this h function is independent of p. So that's why only we have a gp here is equal to dy upon fq. So that is will give me this quantity, that is minus hq is equal to dz upon p gp minus q hq is equal to minus dp upon, it is fx. Fx is nothing but the derivative of this g function, that is gx plus p fz, but fz is 0, so that's why we have 0 here, equal to minus dq upon fy, that is the derivative of this function with respect to y, that is exactly the derivative of h with respect to y, because this is independent of y. So that is minus hy plus q into 0. And we note that gx dx plus gp dp equal to 0. That means I am comparing these two equations here. And if you can solve this one, then it is nothing but the g derivative of g here. So it is, therefore we have g of xp equal to constant, and hence we have h of yq equal to constant, because g is same as h. So this, from this we need to solve for p and q, and from this we can solve for p and q as p equal to g of ax and q equal to h of ay. Then dz is equal to p dx plus q dy. The value of p is this, it is in terms of capital G of ax, some function is there, plus h of ay dy. So if we integrate both sides, then we'll have z is equal to integration of g of ax dx plus integration of h of ay dy plus some constant b is there. So that is our required complete integral that we got. Let us solve some examples related to it. So the example says that find the complete integral of p square plus q square is equal to x plus y. So to solve this one, the auxiliary equation are dx upon fp, that is 2p, is equal to dy upon fq, that is 2q, is equal to dz upon p fp, that is 2p square plus 2q square, is equal to dp minus dp upon fx, that is minus 1, plus P into Fz, that is 0, equal to minus dq upon minus 1 plus 0. So either you can compare the last two, or you can compare this one and this one. Any one of them it will do. So here I am comparing this two equation, that is dx upon dp is equal to dp. So that will gives me dx is equal to 2p dp, and if you take the integration, will gives me x is equal to p square plus some constant a. So this will gives me the value of p will be a plus or minus square root of x plus a. If you want, you can just take the positive square root, no problem with that. And from this, since we have the value of p from the equation, given equation, we can able to find out what is the value of q. So therefore we have here p square plus q square is equal to x plus y. So p square we already have obtained it, that is x minus a. So it is x minus a plus q square is equal to x plus y. X will get cancelled out, so q square will be y plus a. And if you can substitute this value, now the Pfaffian equation, that is dz is equal to p dx plus q dy, will be the value of p is this. So I am just taking the positive square root, dx plus the value of this one is y dy. If I take the integration, that is, then this is a z is equal to the derivative of x raised to minus 1 by 2 is raised to 3 by 2 upon 3 by 2. So it is 2 by 3 x plus a raised to 2 by 3 plus 2 by 3 y plus a raised to 2 by 3 plus some constant d is there. So which is required complete integral of given P.D.E that we have. Now type 4 is known as Clark-2 form, Clarton form, which is of the form z is equal to px plus qy plus g of pq. So it is of this form. If the complete integral of this type, if this is the integral, then the complete integral is given by z is equal to ax plus by plus g of ab. That means we have to just substitute the value of p and q here. And if you want to check that whether it is a solution, is a complete integral, for that you need to check that the rank of matrix is this, that is f a f x a f y a, f b f x b f y b. So you just check that f a is nothing but the derivative of this with respect to x a, that will gives me x plus g a. fx is a, and then if you differentiate that with respect to a, will gives me 1. fy is b, if you differentiate that with respect to a, will be 0. Then fb, that is y plus gb, and fxb, that is the derivative of this quantity with respect to x, will gives me a, and b, if you take again differentiation with respect to b, so that will gives me 0, and then here you will have 1, is of rank 2, and therefore this is a complete integral. That is the definition of the complete integral, is that if this matrix has a rank 2, then it is called a complete integral. Let's solve some examples related to it. Find the complete integral of P.D.E. z is equal to px plus qy plus log of pq. Now the complete integral for this one, it is of the form as we have talked here, it is of this form, px plus qy plus, here g of pq is log of pq. So the complete integral is z is equal to ax plus by plus log of ab, where a and b are arbitrary constants. Let us solve another example. Find the complete integral of P.D.E. That is pq z is equal to p square x q plus p square plus q square y p plus q square. So here this is the equation is there, and if you can write down this equation in the form of by dividing pq both sides, then this will be z is equal to, you just see that q will be cancelled out, we will have left with px, and here it will left with qy if I divide by pq. So this will be p power 4 upon pq is there, but one p is get cancelled out. So that's why let's say p power 4 upon pq, and the last term is q power 4 upon pq. So it is again of the form, the previous form. So the complete integral for this one, z is equal to ax plus by plus a power 4 plus b power 4 upon ab. That's it for this video. If you like this video, please press the like button. If you have any comment, suggestion or a question, please drop down in the comment box below. See you in next video. Till then, bye bye. Sayonara.